3.4, number 20. It says the position x coordinate of a particle moving along the line y equals 2 is given by this equation, where t is time in seconds. Describe the motion of the particle for t greater than 0. So t greater than or equal to 0. So if we just graph that on a calculator, that equation, and looked at it, you can see that it's a cubic. It goes like this. And if we're moving horizontally along the line y equals 2, or if it's an x-axis, you could think of it as this. So this parabola, or this polynomial, is moving to the right, and then left, and then right. So, so if we were on the line y equals 2, here's the line y equals 2, the particle, well, when time is 0, starts at -5, so there's -5. It starts right here, and it moves to the right until it gets to here, and then it goes back left, and then it goes back right, and it goes forever to the right. So if I was going to describe it, I would say, it goes right, left, right. We could be more specific, but that's kind of the shape that it's going to be. Remember that in math, going up is positive or right is positive. So in this case, up is positive, down, and then up positive again. But we're on a number line, so it's going up until it gets to here. So that's right, left, and then right again. Part B, when does the particle speed up or slow down? Okay, that's kind of I'm going to go ahead to part C first. When does the particle change direction? So we know that the particle is changing direction right here and right here. So 2 times. We know that's the case when our velocity is 0. So let's find our velocity. So if we set that equal to 0, we would have the 2 times where the velocity is 0 or where it changes direction. So we could use our quadratic formula, and we get time is about 1.15 and 3.18. So after 1.15 seconds it gets here, and then at 3.18 seconds it's here, and then it takes off. So if I was going to graph the velocity function on top of the position function, just graph that equation. So part C, when does the particle change direction? We got that. Back to part B, when does the particle speed up or slow down? So you know something is speeding up when it's gaining velocity, but it's gaining absolute value of the velocity. So right here, it's slowing down until it gets to right here, and then it's still slowing down because the velocity is decreasing still, but it's actually speeding up. It's gaining more negative velocity. So it's slowing down until it gets to right here, which is 1.15. Now the speed is increasing until it gets to right here, and then the speed is decreasing because it's getting closer and closer to 0, and then the speed increases forever after that. So when is it speeding up? It's speeding up from here, 1.15, to this, whatever that is. I guess we can calculate the minimum unless we wanted to do a derivative. We're on the blue curve, so I'm going to jump by hitting up. Now we're on the left, the red curve, left bound, right bound. Guess I hit the button twice. So the x is 2.17 at that point. So it speeds up from 1.15 to 2.17, and then it's going to speed up after this, so that is at 3.18 to infinity, looks like. It's slowing down anytime the velocity is getting closer to the x-axis. So if the velocity is getting closer to the x-axis, it's slowing down. If the velocity is going away from the x-axis, it's speeding up. So it's slowing down until we get to 1.15, and it's slowing down here to here because it's going toward the x-axis. So 2.172, 3.18. That's when it's slowing down. Let's see. D, when is the particle at rest? Particle is at rest anytime the velocity is 0, so there's your answer for D also. Describe the velocity and speed of the particle. Well, velocity, we've already defined it to be this function right there. The speed, we said, is the absolute value of velocity, so it'd be, that's our speed function. So if I wanted to, I could just take the absolute value of this red, and it's just going to not allow it to go below the x-axis. It's going to bounce off, kind of look like that. So I guess we could do that. Go to y equals, I'm going to insert absolute value. Oh, that didn't let me insert it. 6x squared. Alright, a lot of work to show something we already talked about. Now there's the original. Here comes the speed. No. I think it doesn't like me still having that. Thought I got rid of it. So it bounces off. There's the speed function. It could never go below the x-axis. And F, when is the particle at the point 5, 2? Remember, we're moving along the line y equals 2, so it always has a y value of 2. We just need to know when the x value is 5, because they asked for when it's at 5, 2. So we could just set this equal to 5. So 2t cubed minus 13t squared plus 22t minus 5. When is that equal to 5? Well, I could subtract 5. Okay, so then we just need to find the solution to this. So we could graph that on our calculator. I'm going to change that minus 5 to minus 10. I'm going to turn this one off for right now. Okay, so the answers are going to be right here, and right here. 3 answers. You just have to calculate the 0. So one answer is 4.13, and then you could do that a couple more times.